Hey, grade 6. So, as we've been moving forward, we are now working with multiplication problems that involve decimals, and that can be a little bit scary for some people. Now, we went over all these today in class, but I figured it would be helpful to record something for historical reference for you, so you can always go back and take a look at it if you need it. So, we're going to do a couple of example problems using a couple of methods that hopefully make this whole thing feel a little bit more approachable to you. Now, the first method, and the one that your assignment's about this time around, so you might want to use this for that, is to just get rid of the decimals, but keep an eye on them as you go. So let's try a problem like 23 and 7/10. We're going to keep it simple. We're just going to multiply it by a one-digit number this time, times 4. So the easiest thing we could possibly do here is pretend that this decimal doesn't exist. We're going to get rid of it. But we're going to keep track of it while we do that. To turn 23 and 7/10 into a whole number by moving the decimal, we'd need to move it one place to the right. This will give us, instead of 23 and 7/10, 237. Now, I moved it, so I'm going to write moved dot once. Since I moved it one place and I've now tracked that, I'll have a reminder for when I'm finished this question that I need to move it back. And that's really all that we need to do. Because if I get rid of the decimal, and I just have 237 times 4, that's the kind of problem you've been solving since the 4th grade, if not earlier. So we'll go through, just use the standard algorithm. 4 times 7 is 28. Put the 2 up top for later. 4 times 3 is 12. Add that 2. I've got 14. Put the 1 up top for later. 4 times 2 is 8. Plus that 1 I just saved makes 9. 948. Well, I now know that 237 times 4 is 948. If I put that decimal back in, if I move it back in that one place, then I just have to do the exact same thing with my answer. I move it once. I move the decimal once to get it out. I move it once to put it back in when I'm finished. 23 and 7/10 times 4 is 94 and 8/10. Now, even though having a problem where both numbers have decimals in them is actually beyond the grade 6 level, we're going to do one just to show that it still works like this. Let's try 5 and 3/10 times 4 and 2/10. Well, to turn this into an approachable problem, the kind that you've done before, I need to make this 53 times 42. You can do that. That's a grade 5 question. You've done those at any time. So to do that, I need to move the decimal once here and once here. Now I've got 53 times 42. But it's worth saying, moved decimal twice. Because in my answer, I've moved it twice to get it out. I'm going to have to move it twice back to get it in. Let's solve this problem. 2 times 3 is 6. 2 times 5 is 10. Next up, I multiply my 40 by 53, and since it's 40, I know that number is going to end in a 0. 4 times 3 is 12. Save my 1. 5 times 4 is 20, and 1 more is 21. Add them up. 6, 2, 2, 2. So I have 53 times 42 is 2,226. Well, if I move my decimal twice earlier, I just have to move it twice back now. Should be about here. 5 and 3/10 times 4 and 2/10 is the same 4 digits, but now that decimal's moved twice into them. It's 22 and 26/100. Now I can estimate to prove that this is right to myself by just pretending that those decimals don't exist. What if it's just 5 times 4? 5 times 4 is 20, so 5 and a little bit times 4 and a little bit should be a little bit more than 20. 22 and 26/100 is a little bit more than 20, so I can be pretty confident in my answer here. I moved the decimal away, I solved the problem, I moved it back exactly as far as I moved it to start. That'll work for you, no problem. What if you're somebody, though, who's more comfortable with the lattice method? To remind you of what that is, that's that problem, that's that way of solving a multiplication problem, where we take the digits of one number and the digits of another number and align them around a box. So just to redo the same thing to show you it works, if it was 53 times 42, I would write one number across the top and one number down the side of this weird looking box. In each box, I'd multiply the digits that meet up there, writing the tens part of the answer above the line and the ones part of it below. 3 times 2 is 6, so that's 0 tens and 6 ones. 3 times 4 is 12, 1 10 and 2 ones. 5 times 4 is 20, 2 tens, 0 ones. 5 times 2 is 10, 1 10, 0 ones. Now I just have to add up along the diagonals. 6 plus nothing is 6, 2 plus 0 is 2, 1 plus 0 plus 1 is 2, and 2 plus nothing is 2. This number wrapped around the side is my answer, 2,226. That's your minute-and-a-half long recap on how to use the lattice method. However, if we put a decimal in these problems, we can still track it. And it's very easy if you only have one decimal in your question. Let's try 57, just pulling numbers out of thin air here. 57.3 times 19. Why not? Now for this, I'm going to move this out of the way for a second here. Where's my select? Move this. All right. So for this, I've got a 3-digit number times a 2-digit number, essentially. But I am going to need to keep track of this decimal while I solve it. I'm going to draw the lattice box the exact same way I would for a 3-digit by 2-digit number, leaving room for 2 numbers on the side and 3 on top. I'll put my lines across, of course. So, 57 decimal, I'm going to put my decimal there, and 3/10 times 19. Now, the only thing that's really going to give me trouble here is that I need to make sure my decimal from the question tracks down, follows this line it's on top of, to become a decimal in my answer. If I do that and make sure my decimal's in the answer as well, this is going to be the correct answer for me. So let's run through the boxes. 3 times 9 is 27. 2 tens, 7 ones. 3 times 1 is 3, 0 tens and 3 ones. 1 times 7 is 0 tens and 7 ones. 7 times 9 is 63, 6 tens and 3 ones. 5 times 1 is 0 tens and 5 ones. And finally, 5 times 9 is 45, 4 tens and 5 ones. Add up on the diagonal. 7 plus nothing. 3 plus 2 plus 3 is 8. 0 plus 7 is 7. 7 plus 6 is 13. Plus another 5 is 18. So we're going to put our 8 here and carry our 1 to the next column. 1 plus nothing plus 5 plus 4 is also the same as 5 plus 5. That's 10. So I carry my 1 again. 1 plus nothing is 1. So we see that 57 and 3/10 times 19, if I go from left to right around this box, should equal 1,088 and 7/10. And if you had a calculator handy, you'd see it does. So the lattice method does still work for this as well. If you can solve these problems in any way, you can solve them with a decimal if you just keep your eye on where everything falls. Now the last thing is one more wrinkle on top of all of this that only gets thrown in if you use the lattice method and want to multiply two numbers that have decimals in them. That means this is past grade 6 level. You do not have to worry about this right now. So if you are already satisfied, you can stop the video here and move on with your life. Godspeed, have a good one. For those of you that want to see how the lattice would work with two decimals, we're going to do one more example. And because it's been working for us, we're going to keep that example problem of 53 times 42, but 5 and 3/10 times 4 and 2/10. We're going to make sure that both of our numbers have a decimal. And we've seen this one a couple of times already, so we know what the answer should be. We just need to prove that it will be that. So I'm going to draw my box for the lattice method. It's going to be 2 by 2 because this is 2 digits by 2 digits. I'm going to put my diagonals in, and I'm going to write my numbers on it. 5.3, 4.2. So far, so good. Now, the problem is that when you have two decimals, a 10th times a 10th does not give you a 10th. If you're working with larger place value numbers, a 10 times a 10 doesn't give you a 10, it gives you 100. A 10 times 100 doesn't give you 100, it gives you 1,000. Well, behind the decimals, it works the same way, but everything's got a th now. A 10th times a 10th gives you 100th. A 10th times 100th gives you 1,000th. Everything gets smaller as you multiply decimals by each other. So we're going to need to allow for that. We're going to need the answer to this question to go to the hundreds place. How can we show that? Well, each of these decimals goes down along a line. What we need to do is find a way for them to meet in the middle. What's in the middle of them? Well, that would be putting a decimal in my answer right here, between the two. That's going to make sure that I have enough space for my answer. I could also do this by saying I have one space behind the decimal here on the side number, and one space behind the decimal here on my top number, so my answer is going to need 2 spaces behind the decimal. If I leave those 2 spaces, I can be pretty confident that this is going to be the correct answer. To remind us, we've done this a few times. It's going to be 22 and 26 hundredths. Let's prove that still works. 3 times 2, 0 tens, 6 ones. 3 times 4, 1 10, 2 ones. 5 times 4, 2 tens, 0 ones. And 5 times 2, 1 10, 0 ones. Add them up along the diagonals, same as we've been doing. Got our 6, got our 2, got our 2, got our 2. Again, following it around, we see 22 and 26 hundredths. So hopefully that made sense. Hopefully that tracked for all of you. Really, it is just as simple as these earlier ones we did, where if you move the decimal out, track how far you moved it, and then move it back once you've solved the problem you can already solve and have been solving for years. You're good to go. That's it. Have a great rest of your day, grade 6. Peace.